In this video, I'm going to show you how to solve equations of the form absolute value of ax plus b equals c using an algebraic method. So here we want to solve the absolute value of x equals 5. Remember, the absolute value just works by stripping away any negative sign. So the expression inside the absolute value bars has to be either positive 5 itself, absolute value of positive 5 is 5, or the expression inside can be negative 5 because absolute value just strips away that negative and it still comes out to 5. So either 5 or negative 5 work for the inside expression here. So now we just take what's inside the absolute value, x, and we set it to 5 or negative 5. X equals 5 or x equals negative 5. And, well, there are our solutions. X equals 5 or x equals negative 5. That was pretty easy, but this logic will help us to solve equations involving absolute values that are a bit more complex. Here's another example. Now the expression inside the absolute value is a little bit more complex. We've got not only x, but also x minus 5. But we're going to approach this the same way. So absolute value of some expression equals 2. What can be inside of the absolute value bars? Well, it's either regular 2, positive 2, absolute value of 2 is equal to 2, we know that, or it could be negative 2 because the absolute value of negative 2 just strips away the negative sign and it's also equal to 2. So we've really got two possibilities here. The inside expression here can be equal to 2, let's write that down here, x minus 5 equals 2, or that inside expression can be equal to negative 2. So x minus 5 equals negative 2. And now we just have to solve each of these equations. So this first one, just add 5 to both sides, and you get x equals 7. And then the second one, again, just add 5 to both sides, you get x equals 5 minus 2, which is 3. And there we go. There are our solutions. Just to be absolutely sure of these solutions, let's double check them in the original equation. So plugging in x equals 7 into the original equation, we've got absolute value of 7 minus 5 is equal to 2, and 7 minus 5 is 2. Absolute value of 2 equals 2. Well, yeah, absolute value is just 2. That works out. Okay, and then how about x equals 3? Let's plug that in the same way. So absolute value of 3 minus 5, is that equal to 2? Well, 3 minus 5 is negative 2. Is absolute value of negative 2 equal to 2? Yeah, so 2 equals 2, and there we go. Both solutions are good. Here's another equation that we want to solve, and this one's even more complex. This time we've got absolute value of some expression with x, and we've also got a plus 2, and that's equal to 6. So first step, how do we solve this equation? Well, how do we get it into a form that we are familiar with? We should isolate the absolute value on one side. That's how we've been doing the previous problems. The absolute value has been alone. So let's get that plus 2 out of this left-hand side, bring it to the right-hand side. We can just subtract 2 from both sides, and we'll get absolute value of 2 minus 3x is equal to 6 minus 2, which is 4. Now this is more familiar, so we know how to solve this one. As usual, there are two possibilities for the expression inside of the absolute value bars. Either it could be positive 4, because absolute value of positive 4 is equal to 4, or it could be the negative of that. It could be negative 4. Absolute value of negative 4 is also equal to 4, because it just strips away that negative. So we've got two equations here that we can set up. We can just set the inside of the absolute value bars here equal to 4 or equal to negative 4. Let's go ahead and do that. So we've got 2 minus 3x equals to 4, or 2 minus 3x equals negative 4. And now we just need to solve each of these. So why don't we go ahead and subtract 2 from both sides to get rid of that 2, get negative 3x alone on one side, so negative 3x equals 2, and then divide both sides by negative 3, get x equals negative 2/3. Okay, and then how about the other one? Again, we'll just subtract 2 to get negative 3x equals negative 4 minus 2 is negative 6, and then divide both sides by negative 3, get x equals 2. So there we go. These are our two solutions. I'd encourage you to check these two solutions to get into good habits of checking. We won't actually do it here, but they will work out if you check them by plugging them into the original equation. Here's another example. We want to solve absolute value of 2x plus 1 equals negative 5, and this one might look a little bit intimidating because of this negative right-hand side here. We're not used to seeing that. But actually, this is the easiest one to solve. We don't even have to do any work. We can see right off the bat that there are no solutions to this equation. And why not? Well, absolute value is always either 0 or positive. It can never be negative because it represents the distance from 0. Distance is always 0 or positive. So you can't have a distance that is equal to a negative number. So there's no number that we can stick in that'll make this absolute value equal to a negative number. So without any work whatsoever, we can say that has no solutions. In these examples, the only instance of the variable x was inside of the absolute value bars. However, in the future we'll also learn how to solve equations where the variable appears in two different places, both inside the absolute value and outside the absolute value.